Welcome friends in TEKNOversity. My name is Paresh Vrajlal Shaparia. Friends, today we will learn about what is refining petroleum. Organic hydrocarbon liquid of oil and gas are called petroleum. Oil and gas are extracted from deep oil gas field and transported to refinery. Petroleum also contains inorganic impurities like oxygen, nitrogen, sulfur, salts, water, carbon dioxide, and metals like vanadium, nickel, and iron, etc. Crude oil is a mineral oil consisting of a mixture of hydrocarbons of natural origin, yellow to black in color, and of variable density and viscosity. Petroleum consists mainly following hydrocarbon groups. Number 1 is paraffin. Paraffins are straight carbon-carbon single bond, straight chain compound, methane CH4, ethane C2H6, propane C3H8, and so onward. Methane, ethane, propane having less numbers of carbons are in gaseous state. Structure of propane is as shown. Number 2 is naphthanes. Naphthanes are closed carbon-carbon single bond ring structure. Cyclohexane C6H12 is as shown. Number 3 is olefins. Olefins are also called alkenes. Olefins are straight chain carbon compound with one or more double bond between carbon. Propene C3H6 is shown. Paraffins, naphthanes, acyclic straight olefins are also called aliphatic components. Number 4 is aromatics. Aromatics are closed carbon-carbon alternate double bond ring structure compound. Benzene C6H6 is shown. Crude petroleum producing countries: USA, Russia, Saudi Arabia, Canada, Iraq, China, United Arab Emirates, Brazil, Iran, Kuwait. Majority comes from the above top 10 countries. Organization of the petroleum exporting countries OPEC includes Algeria, Angola, Equatorial Guinea, Gabon, Iran, Iraq, Kuwait, Libya, Nigeria, Republic of the Congo, Venezuela, etc. Crude oil important parameters properties are density, how compact substance is or mass divided by volume, viscosity, resistance to flow, power point, lowest temperature at which oil will flow, read vapor pressure of oil at 38 degrees centigrade, carbon residue, remaining carbon after complete distillation, sulfur indicates sourness in oil. It is poisonous to catalyst, thus corrosion on metals, creates pollution in environment. Nitrogen, it is poisonous to catalyst. Metal, arsenic, lead, nickel, vanadium, they are poisonous to catalyst. Salt, thus corrosion, also poisonous to catalyst. Hydrogen sulfide, H2S, it is toxic. Crude oil is cleaned and then heated in high pressure furnaces to temperature of about 850 to 1000 degrees centigrade. The mixture boils and forming hydrocarbon vapors and liquids that enter the bottom of the distillation column. The lightest fractions rise to the top of the column where they condense back into liquids. Medium weight liquids stay in the middle of the column and the heaviest fractions settle at the bottom. Inside the distillation column, the vapors and liquids separate into components or fractions according to weight and boiling point, and most important, condensing point. Stacks of trays at various intervals collect the liquid hydrocarbons. Bubble caps on the trays slow down the vapors as they rise through the column. The collected liquid fractions pass to other areas via pipes for further processing. Vapors rise through the vertical column As the vapors rise through the column, the temperature decreases. As the temperature decreases, certain hydrocarbon vapors begin to condense at different temperature and run off at different levels depending on condensation point. Liquid fractions are drawn from the trays and removed. In this way, the light gases methane, ethane, propane and butane pass out from the top of the column. Petrol is formed in the top trays, kerosene and gas oils in the middle trays, and fuel oils at the bottom trays. The heaviest fractions of crude oil requires such high temperature to evaporate them that cracking might be occur. In order to avoid this cracking, distillation is carried out under vacuum, thus lowering the boiling point. To recover additional heavy distillates from atmospheric distillation column's residue, it is piped to a second distillation column, where the process is repeated under vacuum, called vacuum distillation. This allows heavy hydrocarbons with boiling points of 500 degrees centigrade and higher to be separated without them cracking into unwanted products such as coke and gas. Useful products such as gasoline, diesel, LPG are recovered from this residue. Final residue drawn from bottom of vacuum distillation is further processed into manufacturing of lubricating oils, waxes, bitumen, asphalt and coke, etc. Refineries process crude oil to form fuels such as LPG, gasoline, kerosene and diesel. The main process steps involved are separation of the crude oil by distillation and subsequent conversion like cracking, reforming and isomerization, treatment process like hydrotreater and Marox, and final blending of finished products. So separation, conversion, treatment and blending are major process in petroleum refinery. Here we can see distillation column operation. In crude distillation plant, crude is purified, heated, stabilized and fed to fractional distillation column. Distillation column consists bubble cap trays, packaging, etc. Based on boiling point and condensing point, different products are taken out. Everything goes inside distillation column is converted to vapors, except very heavy hydrocarbon. This vapor rises up. Temperature inside column is decreasing as we go up inside column. So based on condensation point, products are separated. Bubble cap is a bell-shaped cap which is fixed on the top of a cylindrical risers through which the vapor passes. The bubble caps facilitate continuous contact between the rising vapors and returning liquid. Vapors rises up through bubble cap and condensed liquid flows down from side of trays as shown. We get fuel gas, that is methane, ethane, propane from top at approximately 20 degrees centigrade. Naphtha cuts at approximately 70 degrees centigrade. Petrol or gasoline cuts at 120 degrees centigrade. Kerosene cuts at 170 degrees centigrade. Diesel cuts at 270 degrees centigrade. Lube oil, fuel oil cut at 450 degrees centigrade. From bottom, we get carbon residue at approximately 600 degrees centigrade. Top gases are externally cooled and liquid goes back to tower as reflux and gas goes as product. Bottom residue is heated externally in reboiler Light component goes back to column as reboiled. Heavy component further processed in downside plants. Side strippers. Each tray has the tendency to collect liquid of a small range of boiling points. Although we get mixtures of hydrocarbons in these trays, so it is customary, therefore, to draw the liquid from selected trays out of the main column into a small subsidiary column called a side stripper and allow it to flow down through several bubble trays. While passing over these trays, it meets an upward stream of steam which is injected at the bottom of the stripper. By using two or more of these side strippers in conjunction with one main column, streams of white spirit, kerosene and gas oil can be obtained direct from the plant without further distillation. This arrangement considerably simplifies the production of the various grades of distillates and to manufacture gasolines and the other products with the correct distillation range without the necessity of redistillation. Here you can see sketch of side strippers. Columns. Within refineries, there are numerous other smaller distillation columns designed to separate specific and unique products. For example, a depropanizer is a small column designed to separate propane and lighter gases. Here you can see major petroleum refinery process: separation, conversion, treating and blending, and their process plant name. Type of process: separation of crude oil. Process plant name: atmospheric distillation, vacuum distillation, solvent deasphalting. Type of process: cracking. Process plant name: coking, catalytic cracking, visbreaking, hydrocracking. Type of process: rearrangement. Process plant name: alkylation, reforming, polymerization, isomerization. Type of process: treating. Process plant name: hydrotreating, mercaptan removing. Type of process: blending. Process plant name: blending of products as per requirements. Treatment. Treatment is to prepare hydrocarbon streams for additional processing and to prepare finished products. Treatment includes removal or separation of aromatics, naphthenies, impurities and undesirable contaminants. Treatment may involve chemical or physical separation, for example, dissolving, absorption or precipitation using process including desalting, drying, hydrodesulfurizing, solvent refining, sweetening, solvent extraction and solvent dewaxing. Blending. Blending is the process of mixing and combining hydrocarbon fractions, additives and other components to produce finished products with specific properties. Additive includes octane enhancers, antioxidants, anti-knock agents, gum and rust inhibitors, detergents, etc. Other processes within refinery are light ends recovery, sour water stripping, solid waste, process water and wastewater treatment, hydrogen production, acid and tail gas treatment, and sulfur recovery. Refining petroleum products and their use. Fuel gas, LPG, naphtha, gasoline, kerosene, diesel, polymer, fuel oil, lubrication oil, wax, coke, petrochemical, and sulfur. Thank you friends for watching and giving your valuable time.